Today I'll be briefly going over our Zenith gear pump leakage model for Senior Design 1 of the Fall 2021 semester. Here we have the full-scale overview of our poster that we will be presenting at the Expo. Going into further detail on our project overview, this is a precision metering gear pump with extremely tight tolerances, and our goal here is to create a computational fluid dynamic simulation for the Zenith gear pump line. We are then going to create a standard work for the CFD process, and then in Senior Design 2, we're going to be building a leakage model within Excel to predict flow paths on future pumps. Here we go further into the detailed design with individual modeling of our slip paths within the pump. These three slip paths that we will be covering are the outer diameter / gear tip slip path, the bearing slip path, and the gear face slip path. We have also chosen to simultaneously simulate all three paths at once with a more experimental approach that will be detailed later. In figure 2, you can see our outer diameter and gear face paths, and in figure 3, you can see the bearing face slip path. These are the paths where fluid will be leaking internally within the pump, and we will be analyzing the amount of flow that is being lost to these paths. Further details on our project specifications include making the Excel calculator user-friendly for leakage prediction. We will be considering manufacturing variability, including tolerances within each individual pump that is produced. We will also be considering the possibility of laminar and turbulent flows, and we will also be creating the process manual to be extremely easy to follow to replicate any steps we create. ANSYS CFD software was our chosen software based on the following criteria. It's user-friendly, easy to follow and replicate steps. It's capable of the strict dimensional tolerancing that we need, and it has a low barrier of entry with a student version. Figure 4 details an example of some preliminary meshing that we've done on the gear pump. Figure 5 are some preliminary results based on the meshing, and that shows a pressure gradient with expected low pressure regions and high pressure regions at the inlets and outlets. And figure 6 gives a further detailed view on our radial cut mesh, which is going to cover all three slip paths simultaneously. Our last main deliverable for this project in Senior Design 1 is documentation for both SolidWorks and ANSYS. And here in figure 7, we have an example of how we simplified the gear pump model within SolidWorks. And then as well in figure 8, it's another example of what can be expected in the step-by-step manual that will be finalized at the end of the semester. Our plans moving forward are to analyze and finalize our current CFD results and incorporate those into the Excel leakage model calculations, and then to build the leakage model to be user-friendly and ready to go for future Zenith gear pumps.